G'day Jeff, g'day Pat. How you guys going? You want to just give me a heads up on the sound? I'll make sure I've got the volume set right. We'll give everyone a few minutes. There's 30 registered for this event. So we'll just see. If they don't show up quickly, audio and visual, awesome. If they don't show up, we're recording this, so we'll go ahead with it, and I'll probably join on later. Yeah, excellent. Thanks, Jeff. Otherwise, it might just be us. It might be a quick, quiet evening. So, Jeff, I've got in the toolbar to the right, I've got the presentation as a PDF. I'm sharing that so you can download that and print that out or keep it on a hard drive. That's the new one, Pat, that I unlocked for you this morning. Oh, let me get that there. Right. So we've got to be quick. What's that, 8:30, the State of Origin starts? Already downloaded. Yep, good on you, Jeff. Yeah, maybe that's why. Maybe that's why. All right. I'm going to kick off. If this is just it, that's okay. 8:10. Ooh, geez, we're going to have to be fast. Righto. So I'll just skip that page. There's a video that normally plays on here. All right, so what you're looking at is the circuit diagram for an SCR system on a Volkswagen Audi Group vehicle. I believe this is from a Q5 car fitted with SCR or with AdBlue. Just pay attention to the way these things communicate. So engine control module controls most of the AdBlue system, but it does have a separate heater control module that is referenced back to the ECU. And again, ECU is connected via bus back to our gateway and instrument cluster, because obviously the drivers need to know whether the vehicle is out of AdBlue or whether there's any issues going on with the system. All right, so SCR, or Selective Catalyst Reduction, is an exhaust gas after-treatment system used to reduce the oxides of nitrogen produced during combustion. So it's all about NOx reduction. So only the NOx are specifically targeted and reduced with SCR. It's quite a great system. It does work very well, but it is an expensive system. So it wasn't fitted to a lot of the Volkswagen Audi vehicles. For the simple fact that they thought they could get around it by putting less fuel into the engine to keep the combustion temperature down. And that worked for Volkswagen for a little while until they got caught cheating. All right, so AdBlue is a reducing agent. So to make SCR work, the reducing agent is injected into the exhaust gas flow upstream of a NOx catalyst. And the agent is known as an aqueous urea solution. So AdBlue is just a brand name, but it's basically an aqueous urea, so a watered down urea solution. So they still run an SCR catalyst, a NOx catalyst, similar to a petrol engine. So during a chemical reaction, the urea breaks down the NOx compound and then combines with the new elements to form nitrogen and water. It is very effective. It's something like 99% efficient on NOx systems, on NOx gases. So reducing agents require ammonia to break down the oxides of nitrogen. Although due to ammonia's extremely toxic nature, the agent used in SCR systems is much less concentrated. I believe about 32% ammonia. Yeah, here we go. AdBlue is the common brand, synthetically manufactured reductant using a 32.5 solution of urea in water. So it's definitely not 100% ammonia, which is quite corrosive. So urea-based reductants must be kept within a very narrow temperature range. Most will freeze if the temperatures drop below about 10 degrees, minus 10, and they're very susceptible to bacteria growth and breakdown at temperatures over 70 degrees. Motor vehicles, especially since the tanks are down under the car or close to the exhaust systems. So vehicles using SCR must have a storage system that can encompass the characteristics of urea-based reductants. So it's got to withstand the corrosive nature. The reducing agent or reductant tank contains a delivery module, level evaluation unit, and a heater control module. And that's all inside. It's a bit like an MRA, a fuel pump MRA, but all the information's in there. And again, a control module to look after it. So inside that reductant pump module, heater pot, suction lens and delivery line, heating elements prevent solidification of the urea solution. So again, in cold conditions, which Europe's pretty big on, which is why Audi, Volkswagen use these, they do have to heat the solution, much the same as heating the diesel fuel to stop it starting to solidify. So ambient air and engine temperature are supplied, information is supplied to the module by the engine control unit. The temperature of the stored reductant is supplied to the heater control module by a temperature sensor mounted in that delivery module. So there's a heater control module, so all the information comes via the ECM and down into the heater control module. So the pump. This is the Vag pump in the AdBlue system. The reductant is drawn from the heated pot via a suction lens and filter, so it's a pickup. The pump used in this model is a diaphragm type, but driven by a brushless motor, and again controlled by the engine control module. So we've got a separate heater control module, much the same as a glow plug control module, to keep the urea from freezing, but the pump is solely controlled by ECM. So if you're looking for data on this, and you're in a Vag vehicle, you must go to the drive computer to look for your data. All right, the pump, when the ignition is switched on and operating conditions for the SCR system are met, the pump delivers reductant to an injector at pressures of around 5 bar or roughly 70 psi. So it's reasonably high pressure. Okay, when the engine is switched off, the ECM commands the pump's reversing valve to operate, drawing the reductant out of the delivery line and back into the storage tank. So basically, we don't want urea solution left in this delivery line. Reason being, it's susceptible to bacteria growth, to corrosion, to freezing. The heater is back here in the MRA. So when it's not used, it's actually sucked backwards. Okay, the sensor used for monitoring the reductant pressure is attached to the delivery module. The ECM monitors the analog voltage signal to determine the optimal current supply to the reductant pump. The ECM will regulate this current, which is supplied to the pump in the form of a PWM control to maintain a predefined reductant delivery rate. So it's very similar to what we're seeing with fuel, the pulse width to the pump to maintain our pressure. Under different operating conditions, the liquid will flow differently, so we can just maintain its pressure using PWM. So the level sender unit used in the reductant tank is designed as a multi-sensor array. It's mounted directly into the heater pot. So these sensors aren't a float like we're used to, because they would build up with corrosion, and that we actually see that white corrosion forming quite a lot around the leaks when we have AdBlue systems on the cars. So these things use a slightly different level sender. Oh, excuse me. It's in a capacitive-based sender. So there it is there. They're of the capacitive design and are calibrated to measure different properties of the reducing agent as well as the level. So because the urea solution is a dielectric nature, contamination, biological growth, reductant breakdown, and quality can be determined by the capacitance of the fluid. So that's the fluid's ability to conduct electricity. So basically, it's using a fairly sensitive sensor inside there to measure not only level but bacteria growth and how good the reductant really is. So the injector itself, during operation, the pintle may be held open continuously during high engine NOx production phases, or it might be duty cycle controlled, influencing the quantity of reductant injected. So when we get high NOx production, that's generally under a high-speed cruise when we're producing really high combustion temperatures. So NOx levels increase with combustion temperature, and we can't control that using EGR all the time. It just doesn't work. We can't open an EGR under power because the vehicle will lose power if we open EGR. So EGR really can only be opened at cruise to low throttle positions. The NOx reductant, or the reductant injector, we can open that even under full load conditions. So if we're dumping bucket loads of fuel into that system and lots of compression pressure, big turbo, big boost levels, our cylinder pressures and temperatures go up, so it's a breeding ground for NOx gases. So there's no reason at all, because this is after treatment down in the exhaust, we can't pull that nozzle open wide under those conditions, going up a long hill under power. So the ECM is responsible for the operation and monitoring of the SCR injector and its control circuit. If a failure occurs in the injector or control circuits and reductant is unable to be introduced into the exhaust gas, the ECM will prevent engine start if the failure warnings are repeatedly ignored. So you need to educate your customers if they own a vehicle using SCR. If it runs out of AdBlue, after several attempts at starting the car, it will shut down, it won't start. If a problem happens with this injector, and it's got to be electrical in nature that it can be monitored, so open circuit, corrosion, failure of the solenoid, the ECM will warn the driver until it goes, you know what, I've had enough. We're going to shut this down. Okay, the mix. A mechanical mixer is placed directly downstream from the reductant injector. The mixer functions primarily as an impact service for the injected urea droplets. And these mixers look very much like a cyclone element on the inside. So as exhaust gases come through and the exhaust gases start to twist and spin, the reductant hits that and it also starts to spin and mix with the exhaust gas on its way through. Basically, it's there about spreading the urea solution through the exhaust gas, giving it a really nice even spread. Okay, the reductant droplets are reduced in size and impact with the surface of the mixer. This allows the reducing agent to evaporate and mix into the exhaust gas faster. It also prevents larger spray droplets from impacting directly onto the NOx catalyst. The geometry of the mixer blade causes a swirling effect to the exhaust gas flow. This promotes an even distribution of the reductant system. Okay, urea chemical reaction. After the mixing phase has occurred, the aqueous urea solution undergoes its first reaction with the exhaust gas. This stage is called thermolysis. Well, I sound like a tech teacher. Thermolysis is a chemical reaction in which an initial substance is broken down into several chemicals by means of heating. The reaction occurs as the water contained in the aqueous urea boils off due to the exhaust gas temperature. The remaining compound separates into ammonia and isocyanic acid. There we go. The second stage of the first chemical reaction is known as hydrolysis. Hydrolysis is the cleavage of a chemical compound via its reaction with water. The isocyanic acid reacts with the water vapor to create additional ammonia and carbon dioxide. So now you start to understand why we only have about a 32% mix of urea, because we're creating more ammonia in the exhaust as it breaks down. It's really clever stuff. So the NOx reduction takes place in the reduction catalytic converter. So it's a catalyst, right? So it's going to heat up. It's a reaction between the NOx and ammonia that forms nitrogen and water. So basically, it's breaking the NOx apart, and that's all it's doing. But you need heat. Any catalyst needs heat to work, and that's what the idea of a catalyst is. creates a chemical reaction using heat. The design of the reduction catalytic converter is very similar to that of an oxidation catalytic converter using a honeycomb-shaped ceramic body. The reduction converter's substrate is coated with copper zeolite. This coating accelerates the speed of the NOx reduction process. The normal operating temperature of a typical reduction converter is just on 200 degrees Celsius. If the exhaust temperature drops below this, the chemical reaction is no longer effective, so reduction of the NOx can't occur. Now, in a petrol engine, which is really interesting, same sort of catalyst, same chemical reaction occurs, except we use a reduction agent called rhodium, which is like liquid gold, really, inside our reduction catalyst. But the rhodium reacts more so at a higher temperature. So I think a catalytic converter operates around 350 to, 600 degrees Celsius. It's very, very effective. Over about 600 to 800 degrees, your cat converters really start to melt. So the temperature for a petrol catalytic converter has to be much higher. Great thing about diesels, 200 degrees Celsius, these things work, which is just as well because diesel exhaust temperatures are a lot lower. So to keep it within that range, we have to have some sort of temperature sensing. Exhaust gas temperature sensors located upstream and downstream of the exhaust catalyst or the reduction catalyst monitor and report changes in temperature to the engine control module. Right, so there's our upstream and our downstream sensor. Really similar to what you might see in a DPF system. A NOx sensor is mounted in the exhaust flow directly downstream of the reduction converter. This sensor works in a similar way to a wideband probe, except 2 pump cells and sensing chambers are used. So those of you familiar with the LSU 42 Bosch wideband cell, they only use 1 pumping chamber. The sensor is maintained at a fixed operating temperature using a ceramic heater. The monitoring of NOx gases occurs in the second chamber of the sensor. Now, the current that flows between the 2 electrodes across the pumping chamber is proportional to the NOx present in the exhaust gas. So basically what the ECM is doing, and you would have noticed this when you look at wideband sensors with your scan tool, the ECM is just basically monitoring how much current it takes to flow between these 2 electrodes to keep the cells balanced. If it takes lots of current to keep the cells balanced, then there's a high level of NOx. If there's a low current flow to keep the cells balanced, then the NOx is very low coming out the back. And we can monitor that in a scan tool. So because the produced current values are very low, a NOx sensor module is located very close to the sensor itself. The module converts the current values to a network message, which is then received by the ECM. So this is a Q5 control module. Now this is mounted on basically the chassis rail underneath the engine. Back about here is where the transmission mounts and the exhaust system runs through. And that's your NOx control module there. Just be aware of where it sits. You know, it is a little bit up out of harm's way, but they're using these same sensors on your Q7s. They're using them on the Volkswagen Touareg. So anyone that does a little bit of off-roady mud driving, these modules will be susceptible to water ingress. So keep an eye on them when you get them up on the hoist. So reduction agents have a limited life. It might be necessary to check the condition and serviceability of a urea solution regularly with a designated service tool. Now, most manufacturers just recommend the refractometer rather than a hydrometer. Because we can measure the ammonia content and bacteria level using that. It's a much better tool than a simple hydrometer. Although most people in Australia, they tend to run out of AdBlue before it needs to be, replaced because it's gotten too old. All right, so some common issues that we see with AdBlue systems in VAG vehicles. Reset function is only there when the engine starts. So when we use the Drive Pro scan tool or the Assist Plus scan tool, there is a reset function for AdBlue. and it's in special functions under engine. So that is there only when the vehicle gets towed in a tow truck because the customers ignored the warning signs. And I think it's like 5 engine starts. If they ignore it for that amount of time, it locks down, the vehicle won't start, it has to be towed. So that's when we use the reset function. But you need to fill it up with AdBlue. If you just reset it, the car starts and runs, guess what? Another 5 starts later, it's going to shut down again. So once it's full and it's been reset, the system should reset itself. Heater circuit issues are due to constant operation of this system. So you will see heater control and heater circuit or heater element issues in those pumps. There is software updates for Volkswagen vehicles for engine ECU and SCR, and there are recalls available. So if you've got access to the Irwin system where you can actually see the recalls, or if you've got access to the AutoLogic guided data, check for recalls on that vehicle, and you might find there's something there that we need, or a software update to fix a particular problem. In some cases, and I've seen this, I think, on a little Polo or Golf, when the AdBlue is refilled, the reset procedure doesn't work. So to get around that, remove the fuse for the SCR system so it shuts down completely. It's basically a Microsoft fix to power it down properly. Pop the fuse so it dies, then power it back up. Cycle the ignition until fault code is stored. Then you can clear the fault code and drive the car. The system should perform a self-check and should reset the system by itself. Keep a record of any historic faults. They can affect the reset. So if you're doing a quick test and you're sending it off for support, they're going to want to see any of those previous problems. It just gives us a bit more information, or a bit more of a guide as to why the car's not starting. Okay, so I think there's two issues here that we're going to have a quick look at. I can't remember what vehicle this is on, definitely a Volkswagen of some sort. So the customer complaint was an AdBlue system error. Again, no engine restart. I think that's after 1,000 kilometres. So the fault code logged was a P203B00, and the descriptor of that is sender for level reductant agent, implausible signal. Now, there is a tech bulletin to fix that. So I don't know if anyone's come across this before, but there's the tech bulletin number. Now, if you download this presentation, you'll actually have a copy of that, and then you can actually look that tech bulletin up on the web. Check there's no damage on the cables between the supply module for the reductant agent and control module for the reductant agent. If there are no issues, carry out a software update to the reductant agent control module using whatever code they give you. So pretty basic, that one. Check for damage to the wiring. Check for, again, because it's a implausible signal, don't just do a visual on the wiring. Unplug it. Look for water ingress or moisture ingress. Look for corrosion. Again, just make sure that terminal tension is correct. Okay, next particular one we're going to have a look at, customer complaint. Again, AdBlue system error. No engine restarted 1,000 kilometres. Now the glow plug light's flashing this time. Fault code logged, a P20EE00. So the SCR NOx catalyst, bank 1, effectiveness too low. Then P229F00, sender 2 for NOx bank 1, implausible signal. Now there's a tech bulletin on these. I have seen this code. It's basically, it's logging an implausible signal, or it's logging an incorrect signal because the NOx sensor has failed. No different to when an O2 sensor fails and we start logging lean codes, or when a CAT converters fail and we log a P0430, P420. There's an issue there. On this particular one, it's the NOx sensor that's failed. It's just sending the wrong signal back. Unfortunately, when it sends the wrong signal back, because it's sending back a signal saying that the NOx sensor, the effectiveness of the catalyst is no good, or the effectiveness is very, very low, the engine won't start. That particular one is a replacement of the NOx sensor. Replace that, carry out a road test, good to go. Again, keep these as reference for when you get these vehicles in, because you definitely will. All right, you little beauty. Another nice quick one tonight, all in a half hour. Just as well, because I was told State of Origin starts in about 35 minutes, and we all need to be watching that. All right, that was nice, short, sweet. It was just an overview on the SCR system. Again, download the information, have a look through it. You mightn't have one in the workshop at the moment, but you might get one in, and you need to know how it works to be able to test it. So keep that with you. Right, have I got any questions that you'd like answered before we move on? No worries, Pat. I try to get that through quick because we all want to watch the footy tonight. All right, good work, guys. Okay, well, I hope you all have a nice evening. I'll leave the chat box open for a little bit long. Go New South Wales, yes. I'm very close to the border, though. I'm very, very close to the border up here. I've nearly got to swing the other way, but we'll see. No worries, Frank. Good to see you. Thanks for coming back in. All right, guys. I'll leave this chat box open. If you do have any questions, just throw them in there. I'll answer it while I have my coffee. Other than that, I hope you have a lovely evening. Next week, I think we've got, I can't remember if we've got a Mercedes or a, Jag training next week. So next Wednesday night, there's some info on the new Jag Ingenium engines. The week after that, we're going to run the Mercedes webinar. And then the week after that, I think we're back to some Picoscope information. So I'll keep you all posted, and I'll talk to you then.